I'm Brendan McAdams. Those of you who haven't met me before, we just did a panel where Brian talked up all my accomplishments, quote unquote. I've done a lot in the Scala community since about 2009. I was at MongoDB for about 2 years or so, where I worked on the official driver for Scala and MongoDB. I spent a year at TypeSafe doing consulting and training, and I most recently was at Netflix doing Scala as well. And while I was at Netflix, I found all of these cool libraries for doing functional programming, and I started to go down that road without necessarily meaning to. I was very skeptical about these things for a long time, and I want to talk to you about some of the gateway drugs of this functional programming, some of the tools that I found really useful, and give you a gentle introduction to these things so that hopefully you have something that you can go home with and play with. So the first thing is we're not going to use the Z word. Wait, no, wrong slides. We are going to use the Z word, so I did lie just a little bit. We are going to talk about scalaz. This is the library in particular that we're using. Hopefully at some point I will have cats in this talk as well, and we're waiting on Eric for that. But scalaz right now is sort of the library that you're using for these kinds of constructs. There are similar tools and other things. Cats has a lot of the same structures down the road. But I want to talk about scalaz in particular because this is the tool that I've been using. This is a tool that I've put in production, and it's worked really well for me. So to start with, and I've already kind of indicated it a little bit, how I've traditionally seen scalaz, very intimidating. I mean, for me, it was something that, okay, I'm just going to avoid this. I'm not going to talk about it. I'm not going to think about it. I'm just going to work with what I have. And people always speak about this as being more pure or Haskell-y or mathy, as if these are good things. And for me, that's not necessarily the case. I mean, these are not necessarily arguments that make me think, wow, it's more like Haskell. If only I had Haskell in Scala. So, since we don't have Haskell-ator yet, we're going to go with what we have. And so this wasn't a compelling argument. And I don't have a CS degree. I'm not that great at math. I mean, it turns out I'm okay with the calculus stuff and everything else, but the furthest I got was high school mathematics, and that's, not very useful. And then the biggest question that comes up is, what's wrong with what's in Scala already? What do I not have that I need? And the reality that I've found about scalaz is that it's magic, which is also maybe not the best truth here, but I found it really useful. I found that I went home the first day that I really accomplished something with scalaz, feeling that sort of magical feeling of I've accomplished something and I've opened a new world for myself. And so the road that I went down to scalaz, the biggest thing is once I got started, it was hard to stop. It was hard to not want to find that next tool that I need to use and go down that road and find the next greatest thing. The constructs are really powerful, and they're not actually that hard to use once you figure out what you're doing and what they're for. The symbols can be a little daunting, and we'll talk about those. I am not an expert. I would not stand here and say that I am an expert on functional programming or scalaz programming or anything else. I'm an excited amateur. Maybe on more of the OO functional side with the experience I've had, I'd be a little more comfortable describing myself as an expert. But when it comes to scalaz, I'm nowhere even past amateur. This is not a category theory talk. This is not a Haskell talk. I'm trying to be practical. I want to talk about things in terms of what you can accomplish with these tools, because otherwise there's no real point in us doing this. I mean, we're just thinking. And I would rather you think about something useful. So the road continues with, this is what I want you to learn today. Hey, this stuff may be useful. If you leave at the end of this talk thinking, hey, this stuff may be useful, I'm happy I've accomplished what I set out to accomplish. We are not going to talk about the fact that a monad is a monoid in the category of endofunctors. I might use words like monad and functor, but we'll stay away from those for the most part. I want to at least have a word that you can associate with when somebody says monad, you go, oh yeah, that thing is a monad. So the problems that I had to solve, because for me, this was a problem of having a practical problem in production that I was trying to come up with a better solution to. And we were building an API server that was part of a larger application. We had a team using AngularJS, building their UI to make REST calls to a backend. And the problem that we had was error passing, giving them good errors, validating input, things like you sent me a request object. Are the attributes in this request object valid? Is this a good user? Is this a good company? Are these attributes correct? Now, not all of this would be error message that I want to return to production, but think about development. Think about the fact that you've got 30 errors in something that somebody sent. And if they're in development, it might be nice to tell them all of these errors so they can fix them instead of fixing them one by one. And so we were really working with 500s and throwing exceptions to start with. And they complicate and frustrate for a front-end developer who's not normally working in Scala, who has to dig through Scala error logs. It's not the world's greatest error-solving approach. So we want to help developers help themselves here. And so if an error occurred, there's lots of different errors that can happen that we're worried about. Did the API receive bad data? Did the JSON fail to parse? We could maybe give information about why the JSON failed to parse. If you're using JSON for S, I believe it will give you a dump of exactly what went wrong. Did the database fail? Because this is a separate situation from you sent me bad data. The database failed, tells the developer that maybe there's something different going on. Did something other that's really weird happen? So what if multiple errors occurred? And this is the first place I started, so actually this talk is in reverse of the order that I started, because the second thing I started with, the first thing I started with is the second thing we're going to talk about, because I was trying to solve this problem first, which is multiple errors. But how do we communicate all of these things effectively? To the fact that a front-end developer who's working with our back-end application can actually understand what happened without digging through the error logs, because let me tell you, they just love digging through error logs. As much as I love digging through error logs. So the first thing that we can look at is either. Scala's either. It's a common tool. It's got left and right projections. By convention, left is an error, right is success. This is sort of what people have agreed upon as the way that we approach it. And it's a good concept, but there are some limitations in what we can do. And very briefly, I have got an instance of either here, where I've instantiated right, which is success. I can ask, is this a right, is this a left? But the problem is if we try to iterate over this, we can't do computation over this. It's not a monad. We can't extract it this way. We can't stick it into a for comprehension. So we can force a right projection or a left projection, which solve this. But it's not exactly like if I have an object, I expect to be able to use it the way that I want to use it. I expect to be able to stick that in a for comprehension if that's the way that it's supposed to be used. I can put an option in a for comprehension and extract out info, so why can't I do that with an either? So now it's time to talk about the much vaunted scalaz, or for the Muppet Show, depending on your approach. So disjunctions are the first thing we're going to talk about, and this is already, we're going to get into symbols, and you're going to have to remember some symbols. Scalaz's // also known as disjunction, which we're going to mostly use the word disjunction here. I'm not going to keep saying // if I can avoid it. It's similar to either. It's the same idea. It's a logical disjunction. By convention, the right is success, the left is failure. Now there's a couple more symbols here. We've got minus // which is left, and // minus, which is right. The easiest way to remember these, the dash is on the side of the disjunction that represents which side of the disjunction it is. Hopefully that was the way that I remembered it. Hopefully that'll work for you. Disjunctions assume that we prefer success, which is the right side. This is another reason with disjunctions you really want to use the right as success, unless you have a specific reason not to, because there is what's known as right bias. The disjunction is biased towards the right-hand side. It provides a bunch of constructs for us that we can lean towards the right if this is what we want to do. We want to treat success like success. And so with things like for comprehensions, map and flat map statements, we can unpack disjunctions. Success, which is the right disjunction, continues, and failures, which is the left disjunction, abort. So suddenly we have this useful tool. If we have a success, we will continue to do what we do. Otherwise, we can return an error and abort. So a quick best practice, when you declare types with disjunctions in Scala, or with scalaz, you should prefer what's known as the infix notation. So you can actually say this, error or left, disjunction right or success. And that, I think, reads more clearly to people, that you see the left side and the right side with the disjunction, as opposed to a standard notation like this, where we say disjunction and our error type and our success type. I think it's a readability thing. The convention that I seem to have stumbled upon with people is to prefer the infix notation. And so with this, we sort of have a little better readability. We indicate which is the left and which is the right simply by which side of the disjunction that they're expressed on. So this is a start with disjunction. Now, I have gone with the most basic imports here, which is the wildcard, I have no idea what I'm doing import. There are more specific, less wide imports that we can do, but you can start with import scalaz_, and then import capital scalaz_, which will get you all of the objects from scalaz and all of the implicits. And you can narrow your imports from there once you sort of figure out what you're doing. So we have postfix operators. We can call .right and .left, which will return to us a right or a left based on whatever object we call. It will wrap the object in a disjunction. We also have explicit left and right methods on the singleton for disjunction. So you can say disjunction.left, disjunction.right, and get back an explicit instance of that. Finally, if you really want to go down this road, you can go fully symbolic with explicit constructors of left disjunction and right disjunction. When I started playing with this, it was recommended to me by a few people to avoid this way of doing things because it's a little less clear. I would recommend you go with this way. This is usually what I do. Postfix notation is also a little confusing because people may miss that postfix. They may miss the fact that you've called .left on a string. And so this is probably your best route to go down. But you do have this. You can explicitly construct this as you need to. Now, these can also be used in pattern matches. So you can say case, left disjunction, whatever the value is, just like you can in any normal case class or option extraction in Scala. So quick digression, speaking of option. Scala's option is a pretty common container in Scala. We use this a lot. We have two sides of it. It's got a none type, which means there's nothing here, without the worry of a null pointer exception, which as much as we all enjoy null pointer exceptions, I like to avoid them myself. I enjoy not having to type if blah, blah, blah equals null. And then we have a sum subtype, and a sum has a value. So this is an indication of nothing is there or something is there. Like disjunction, there's also a bias towards success with option. That bias is towards sum. You can iterate over it, comprehend over it, etc. But the problem is you have what I think of as undiagnosed aborts. Things fail and you're not sure why they failed. You just get a none back out of the comprehension. So this is a couple pieces of sample data that we're going to work with. I've got a case class for address, a case class for user, a case class for a database object, which is just an ID and a user. A user has an address. So I've constructed myself here, user Brendan, which has a database object and a user. And then I've constructed some other guy who's got an ID but no database object. I'm sorry, no user object. So here we've got a user with a user object and a user with no user object. So if we stick these in a comprehension, I comprehend over, extract the database object, and extract the user object, and I yield user. I get back a sum of the user. Because each step, the database object was an option. Iterating over that gives me out sum. Iterating over the user object gives me out sum. But with that second one, we have a problem because there is no user object, which means that what we get out is none. Now imagine if I had stacked this 15 deep. Maybe we're doing something like extract the user object, then use that user ID to get their company, and use their company to get some other relationship that this is part of. Now which of those options returned none? Because as soon as you return none, the for comprehension will yield none from that loop. So which part of this failed is the big question that we have. We can solve this with disjunction. So comprehending over groups of option leads to silent failure. We're not always sure why something failed or where it failed. And I realize that the animation is more distracting. Luckily, it's over. I could have put the sound on, if that helps. So luckily, scalaz includes implicits that help us convert between option and disjunction. And so the right bias of a disjunction makes it really easy to comprehend over. We can comprehend on it just like we can with an option. But when there's a failure, we get left out. So we get that error condition, in which is an object. It has a value, unlike none. So on a left, we will get potentially useful information. So let's look at what that looks like. Here, I have two ways of expressing this. I have \/ , which is the same thing as saying to right disjunction. It's up to you whether you want it to be concise or be readable. To-right disjunction is very clear that you're converting this to a right-hand disjunction. Now that constructor argument, to-right disjunction, what we're saying is, I want you to attempt to convert this option to a disjunction with a right bias. So that means if it's some, convert it to right. If it's not some, then I want the none to have a value of this. So if it fails to convert, which it does with none, none to right disjunction returns that constructor. So we get back a left of no object found. With some, it converts to what it was. We get my hovercraft is full of eels here. And so to-right disjunction is trying to convert a sum to a right disjunction, and if it fails, it's using that constructor argument to give us out the left-hand side. I can comprehend over this, and this is actually in the code base that I most recently worked on, where we started moving to disjunctions instead of comprehending over options. This became a very common sight. We had lots of code that was returning options. Rather than rewriting all of those methods, we simply convert them in place to disjunctions. So I can say Brendan to right disjunction, no user by that ID. User, right disjunction, join failed, no user object. And so for this second user, suddenly I have a useful piece of information. Again, imagine this is 15 deep. Well, now I can return to the front end, sorry, there is no valid user by that name, or there is no valid information enclosed in this. So we have a lot more useful information about what our failure condition was. But what if we want to do something beyond comprehensions? What if we want something more powerful? We want to combine lots of pieces of information or return multiple errors. This is where validation comes in. So this is the place where I started first, and it turns out that it wasn't the right place to start, but disjunction was. So validation was what led me into Scala Z, because I heard great things about having multiple errors all put together. So validation looks very similar to disjunction when you look at it at first glance, but you can convert between them. And the subtypes are success and failure. So rather than left and right, or backslash forward slash, you have success and failure. So it's a little clearer about the fact that it's success or failure, and there's an obvious bias here. Validation is not a monad. So among other things, that means that we can't put it in a for comprehension without converting it to a disjunction. What it is an applicative functor. And the functor maps between two categories. We can change one thing to another thing. And with applicative, we can apply a function to it. And the nice thing here is that we can use that to chain multiple validations together. We can take these pieces of information and accrue additional information about what has happened. So if any failure occurs in the chain with a validation, the failure wins. The errors will all get appended together, which we'll see, as much as I want to leave Swedish Chef up on the screen. So I've created a couple sample users here. We've got Brendan, California with an address. We've got Cthulhu. We've got no such person, and then we've got Hobo Joe, which for a long time was John Pretty because he was traveling a lot, but now is Hobo Joe, because I felt bad about using John as a bad example. So we've got a couple of case class instances here that we can use as we go along. Now I've constructed a method called validDBUser, which I've added some spacing here to make it a little easier to read. But most importantly, I've made this return a validation where failure is string and success is user. So if this fails, I will return a string with an error message. If it succeeds, I'm going to return a user object. So I do a dbobj.user match. If it's a user, then I return success of user. Otherwise, I return a failure. Database object does not contain a user object. So this checks whether a DB object has a valid user in it or not. And so valid DB user Brendan is successive user. Valid DB user of Cthulhu is successive user. Valid DB user of no such person does not contain a user object. It's a failure. But Hobo Joe, who has no address, is still a valid user because he is a user object. This is a more complicated method, which also returns a validation. This, given a user, is going to return to us either an error message of string or an address object. And so I've got a match here on my nested sums with a pattern guard. So I say if it's a sum with a user and the address is valid. We're not going to show the valid post office address method. Just assume that there's a method here that tells us whether the post office recognizes an address. So if it is, then we return address success. Otherwise, we say the address is not recognized by the Postal Service with a failure. And user has no address is a failure, and there's no such user is a failure. So we've got a couple of error conditions that can happen here, both on the is this a valid user, and this is a valid address. And so valid address returns success. It returns failure in the case where Rylai is not a valid mail carrier. The post office does not deliver there. No such user has no user. And then Hobo Joe has no address. So we've got a couple of different examples of these conditions. Now what if we want to chain these together? What if I want to check 5 or 6 or 7 or 70 conditions when I get an object and I want to see all of these things? You get a request object in from the front end. You want to validate all of these steps. So we can stick these together with a number of applicative operators that combine validation results. So star greater than and less than star are two examples. I think you can think of them as left-hand side and right-hand side. And you'll run into these first. So star greater than, or right-hand side, takes the right-hand value and discards the left by default. Less than star takes the left-hand value and discards the right. So when we take these two things, however, errors win. So it's almost like a Boolean or, where it's sort of, if it's success unless there's an error or a false, in which case the error wins. So here, sum of 1, star greater than sum of 2, because we're pointing at the right-hand side, gives us sum of 2. Sum of 1, left-hand side of 2 of sum, returns to us the left side. But when we get into nones, even though we're pointing at the left here with 1.sum, we get a none back because the error wins, regardless of the fact that we said discard the right and take the left. It's like a Boolean or. So that right-hand side wins because it's an error. And then the same thing on the bottom where we point to the right, because the left-hand side is a none, which means that error wins. By itself, not terribly useful, but you should keep in mind that with validation, it's going to chain together all of the errors that occur instead of short-circuiting. And let's take a look at what that looks like. So valid DB user Brendan combined with valid address, because I said give me the right-hand side and ignore the left, is going to give me an address of Sunnyvale. Valid DB user of Cthulhu combined with address is going to give us not recognized by Postal Service. Hobo Joe is going to give us no such address. But here's where it gets weird. What happened with this last one? Blah, blah, blah does not contain a user object, no such user. It's one big string that's globbed together. And so the way that star greater than is called on validation, it sticks all of these errors together. It's actually defined inside of validation what to do when you get an apply of this type. So we need one more tool to make this make sense. One more object that scalaz gives us. So I said there was going to be 2. I actually lied. There's 3. But the third one is really easy because it's just a Scala list. It's called NonEmptyList. And you might guess that a NonEmptyList is a list that's not empty. And so a NonEmptyList is a scalaz list. It's an actual Scala list. It conforms to the collection library. It follows all the rules of the collection library. But it's guaranteed to have at least one element. So there's an invariant on construction that says that when you construct a non-empty list, there has to be at least one element in it. Which is nice because when I give you a non-empty list, you go, oh, this has to have at least one element in it. You don't have to worry about .head blowing up. So this is very commonly used with validation to accrue multiple error messages together. This is that part that led me into scalaz initially, was I wanted these multiple errors. And it's so common that there's actually a type alias. So you could say validation non-empty list failure and right, or success, or you can say validation NEL failure right. That's an alias. That means that the left-hand side, the failure, is a non-empty list of failure. So there's that nice little alias there built in for you. Actually, is it lowercase el? I think it might be lowercase el. So like a list, because it is a list, append accrues multiple elements. You append something to a list, you get a new list with that element added to the list. So what this looks like, I've changed over valid DB user. It's now a validation of non-empty list of string and user. So note that user is still a single element. But the error condition is a non-empty list of string, which means if I get back a non-empty list of string, I know there's at least one error message in there. So nothing else has changed in my object other than the fact that I'm returning a non-empty list of failure. We can be explicit and construct that non-empty list by hand, or we can use some helpers like .failure_NEL. .failure_NEL will return to us an instance of failure of non-empty list. I've also used that alias here, and I'm sorry, it is lowercase el. I think in the old versions of Scala Z, it was capital EL, and that's been deprecated. So you should use NEL with a lowercase e and l. Now, combining together no such person and no such person's user and address, suddenly instead of that glob together string, we get a list of errors. I get back a non-empty list with two elements in it. The first is does not contain a user object, and the second is there's no user here. So those two operations, both errors, got combined together, and now I have a chain of validations that return to me one set of error messages that I can return to the UI, or I can log to the database, or something else useful about what has occurred. So there's one last operator I want to show you. Scala Z provides one more operator that we're going to talk about, which is another one of these symbols. I know, it's really helpful. At the end, we're going to talk about what to call this, which is, I'll give you information on what to call this. But think of this as pipe at pipe. This combines all of the failures and all of the success conditions, whereas with star greater than and less than star, you discard one side, but failures get stuck together. With pipe at pipe, you get all of the success conditions too. And the way that you do that is by providing a partial function. Think of this as a series of case statements, which is what it is, without the match. So you provide case statements that say, if this succeeded, take all the objects together. Because what you'll get is a tuple with every success condition. So this is an example. I've combined valid DB user and valid address, and I've got a case statement that expects a tuple of user and address. Because valid DB user returns a user if it succeeds. Valid address returns an address if it succeeds. And so this case statement is looking for, if you succeed, you're going to get a tuple back with a user and address. And so you can combine these together to have one thing that's done with the success. Other users will return a non-empty list of errors, just like it would with star greater than. So the same block of code with no such person is going to give us the same non-empty list. Does not contain a user object and no such user. So this is used to combine where we want all of the success conditions too, because with the old one with star greater than, we discarded the left-hand side if it succeeded. So no such person gets a combined list. So I talked about one last operator. Let's talk about one last function as well. That last function is dealing sanely with errors. It's always a challenge. And so there's a couple different ways in Scala that we can do this. ScalaUtil_try made its debut in, I think, 2.10. That was originally developed at Twitter. And you use that, you get success or failure back from that. Scala Z offers a higher order function called from_try_catch_throwable on disjunction. The problem with ScalaUtil_try is you don't get to say what exceptions to catch. It catches everything. With disjunction from_try_catch_throwable, we can specify what exception we want to catch. So it looks a little more like a try-catch statement without having a try-catch statement. And then you have this consistent error handler, which is disjunction. So you specify your return type, the type of exception to catch, and your function body. And it will execute this and wrap that so that you either get a left disjunction or a right disjunction based on what has occurred. So here is a great function to wrap, foo.toInt. If we're doing web development, I do a lot of web development. This is common because you're expecting an integer, but what comes in from the UI is a string, and you need to convert that to an integer. So foo.toInt is going to blow up with a number format exception. So I might want to wrap this in a from_try_catch_throwable. Now this is where it gets a little tricky. For some reason that I'm not entirely clear on, success is on the left and failure is on the right. Otherwise, it's fairly consistent. So in this case, you specify your success type and your exception to catch. So here, my block of code, foo.toInt, gets caught in a left disjunction of number format exception. So suddenly I have a common container that I can use to handle these errors and pass them up without a bunch of try-catch statements. So everything is consistent. Now, we can also be less specific in the type of exception to catch. We can widen that type out to exception here, and that will work as well. And we'll get back a left disjunction of number format exception. But the type of exception matters. If you don't specify an exception that's thrown, it will still be thrown. So here, if I'm looking for a SQL exception, a number format exception is going to actually get tossed back up the stack, just like it would if I didn't have a try-catch statement. So keep that in mind, that the type matters for what you're catching. There's also try-catch non-fatal, which will catch anything that's not classified as Scala util control non-fatal. So things that aren't runtime exceptions will be caught by try-catch non-fatal. This doesn't take a type argument. This just catches whatever. So try-catch non-fatal takes your success type only and will return a disjunction. So I promised we would talk about these symbols. This is my final thought on naming things. From the skeptical side, and this is still something that I struggle with every day, and I admit it fully, the use of symbols gets really, really interesting. What do you call these things? I'm sitting here saying \/ greater than and star greater than. I mean, like, you've got to have names for things. You've got to have something, at least within your own team, that you agree is what you call this thing, so that everyone is on the same page. Although it's defined in the file either.scala, disjunction is easily confused with Scala's built-in either. So, calling it a disjunction means that, hey, we're talking about the scalaz either, not the Scala either. And so a disjunction is what we call it, and it's what I call it, and at least that means we're on the same page. Here's a few of the names that I've heard used in the community for pipe at pipe. There's also a Unicode alias of a star inside of a circle, which is really helpful too, because it looks nothing like a pipe at pipe. The thing about this talk that I love is every time I give this talk, somebody usually gives me one or two more names to add, so it's gotten a little ridiculous. The first one is oink. This seems to be the most common name for it. It looks like a pig's curly tail. So oink. I called it a cinnamon bun or a Cinnabon. I am not being paid by Cinnabon for this sponsorship, but I'm having them set up a stand outside so you can get your cinnamon buns after this. Dick Wall also pointed out that in Britain this is called it's a similar thing to a Chelsea bun, which is just a panel raisin. It's a raisin roll. It looks a lot like a cinnamon bun. A TIE fighter. Jason Swartz looked at this the first time and said it's a TIE fighter, which means it also looks a little like Princess Leia's hair. I heard somebody call it Admiral Akbar. I'm not sure what they were thinking. We have Scream, which is getting a little closer. Scream 2, if you want to go with the Wes Craven approach. Home Alone. And finally, I'm proposing we go with the My Little Pony and call it Pinkie Pie. So that said, I mean, thinking about symbols, think about how important they are. Names for things matter. If I kept referring to all of you as hey you, nobody would know who I was addressing. I at least got to point at one of you. But if you have a name, I can say hey Eric or hey Catherine, and people at least have a vague idea of who I'm talking to. Would you like to know more, though, about these things? So the two resources that I recommend, the things that were most useful for me, the first one is Eugene Yokota, and I may probably am mispronouncing his last name. I'm sorry, Eugene. He has a free website called Learning Scalaz that's really awesome. It's a little hardcore, but it gives you a lot of information. It's paired with a book, and I hate to say it, but if you want to know more about Scalaz, you might need to learn a little bit of Haskell. And so Eugene's blog, what he does is he says, let's assume that you're reading Learn You a Haskell for Great Good. And each day, will go through and convert what you've learned in Learn You a Haskell for Great Good into something more useful in scalaz ed. And now I'm going to get flack for saying that scalaz ed is more useful than Haskell. Should be more careful there. Learn You a Haskell for Great Good is actually a free book. You can get printed versions. The printed version is really nice. It's got lots of pretty pictures. But it's also available as a free website. So these are the two things that if you really wanted to get hardcore about this, if you wanted to learn more and understand more, these two things paired together. The website in particular is fantastic. It explains things in simpler terms. It does comparisons to what's in Haskell, but you can also read it without the Haskell guide. And that said, I will open the floor to questions. Yes, Brian. Oh, hold on. We need to get the microphone. Is there a microphone for questions? That way the question is on the recording.
So have you looked at Bill Venner's Scalactic at all? And if so, how would you contrast it with some of the stuff you've talked about here?
I've only looked at Bill Venner's Scalactic a little bit. Scalactic is a library that Bill wrote that has things like, he actually calls it OR, disjunctions. It has some of the concepts from functional programming. Bill has built this partly as a foundation to Scala test. If you're using the latest version of Scala test, you're using Scalactic. I haven't given it the due consideration that I should, despite Bill's best efforts, because I was already down this road of scalaz ed. I think there's a lot of things that are useful there. I don't recall if Scalactic has a validation type. It definitely has a disjunction that's a little clearer than than // But it's something I would recommend as well, and I should have that on my resources, is take a look at Bill Venner's Scalactic. I think it's scalactic.org, as in galactic, only with Scala at the beginning. Other questions? Nobody else? You're all thoroughly confused now? All right, well, if there's no other questions, then thank you very much for your time.